Example 7, which is continued to example 6. Find the coordinate of the stationary point of the curve y equal to negative x cubed plus 9x squared minus 15x plus 11. And hence, determine the maximum and minimum point. From question 6, we already obtained the stationary point, which are 1, 4, and 5, 36. Okay, maybe you can refer back to the question 6. Okay, after we get the stationary point, now we want to test for the point. For this question, I will use the first derivative test to test the 2 points. Okay, to solve by using the first derivative test, some of them they will use the number line. Okay, or some of them they will transform into the table. Now we want to test for the point 1 and point 5. Okay, now let us test for the point 1, 4 first. As we know, x equal to 1 and 5 is a stationary point or is a turning point. Now we want to test the behavior of the gradient of tangent for the interval before 1 and after 1. Okay? Some of them, they will draw a table to solve this question. But actually, they are same. Okay? Now we substitute our x. 1 we put at the middle column. We can choose a number which is less than 1. So maybe you can choose 0. And then we put here 0. Okay? For the number greater than 1, we can choose 2. And we write here 2. Now we can substitute the x into our dy dx to test the behavior of the gradient of the tangent. Okay, so this is our rho dy dx. And this is our rho for slope. Okay, so our dy dx is equal to negative 3x squared plus 18x minus 15. Okay, so now we try to substitute 0 into our dy dx. So we will get equal to negative 3 0 square plus 18 multiplied by 0 minus 15. Okay, we will get the value negative 15, which is negative value. So we write here negative. Okay, here negative. When we substitute 1 into our dy dx, sure we will get 0. Now we try to substitute 2 into our dy dx. So we will get negative 3 multiplied by 2 square plus 18 multiplied by 2 minus 15. Okay, you will get a value equal to 9, which is a positive value. Okay, so we write here positive. Means the interval after 1 is positive. Okay, what's the meaning of positive and negative? Meaning that the behavior of the gradient either is increasing or decreasing. Okay, so for negative, the slope will decrease. 0, horizontal line, and then positive is increasing. Okay, if you use the number line also same, we can notice that the gradient before 1 is decreasing and after 1 is increasing. Okay, that's why I say if you use the number line and table, actually they are same. So we can conclude that 1, 4 is a minimum point. Now we test for the point 5, 36. Okay, the same thing, we can draw a table. Okay, after that we will choose one value which is less than 5. Okay, so we can choose 4 to test the gradient. And a value after 5, maybe we can choose 6 and we write here 6. Okay, so we'll substitute all this value of x into our dy dx. So when we substitute 4 into our dy dx, you will get equal to 9. Means that is positive. So we write here positive. Okay, when we substitute 5, so we get 0. And now we substitute 6. After calculate, we will get a value negative 15, which is negative value. So we put here negative. So we can look at the slope. If positive means the gradient will increasing, 0 means horizontal, and negative means decreasing. Okay, same as in the number line, means positive is increase and negative is decrease. So from here we can conclude that 536 is a maximum point. After we test by using the first derivative test, now we can come out with the conclusion. Okay, we can write 14 is a minimum point and 536 is a maximum point. So that's all for first derivative test.